us today are Karina Shedrofsky from OCCRP and Ian Knopke from Reuters, who will be taking us through their presentation. Ian and Karina, welcome. I leave it to you now.
Thanks. Just pulling up the presentation. You can see that, right?
Yes, we can see it.
Cool. All right, let's get started. So hi, I'm Karina Shedrofsky. I am one of the co-presenters for the TIMELARK group today. And I can't change slides. Okay, here we go. Just to start off, I'm going to quickly introduce the team again. As Lakshmi said, we are a team made up of journalists and technologists from the BBC, OCCRP, and Reuters. So from the BBC side, we had Ned and Galen. From OCCRP, there was myself and Jan. And from Reuters, we had Evangeline and Ian. So what is TIMELARK? As you know, in short, as Lakshmi also said in the introduction, it's basically a journalistic research tool to make complex timelines easy to explore and understand. So what do we actually mean by that? We are taking information that is time sensitive from unstructured data and putting it in a structured format so journalists can actually quickly see how events and relationships and such have changed over time in a more structured and easy to navigate way. So how exactly does it work? First, we use machine learning to extract and map information from text. In this case, we took information meaning entities and relationships between entities, and text meaning from unstructured news stories. Then we went and created a temporal knowledge graph of these relationships. So first you can see that different entities are related to each other, but also giving these relationships an actual timestamp so you can easily see how these relationships may have changed over time. And then at the end, we basically, once you have all of this together, you users of the tool can query for entities, see a time frame of how this entity may have relationships with other entities, and the time frame of how those may have changed over time, as I said. As I think most other groups did, we wanted to start small. So we chose a use case, and we chose the war in Ukraine. So to start off, I think this tool would be pretty useful for lots of different use cases, but we wanted to kind of create a main user persona that would, get the most out of a tool such as TIMELARK. So in this instance, we created a persona, which is a London-based journalist that's covering the war in Ukraine for a major news organization. And they were assigned the task of writing a profile on an oligarch. As a journalist sets out to write a profile like this, they want to understand that person, who they've been connected to over time, what organizations, and how have these things evolved as time has gone on. Obviously, you can spend days and hours sifting through news archives and other unstructured data, but usually journalists are on tight deadlines. So these were kind of challenges that we foresaw that we were trying to address. So using TIMELARK, they could quickly search in the oligarch's, type in the oligarch's name, and see all of the relationships that have been pulled from previous reporting or news articles or other unstructured data, and find maybe not so find relationships, how they've changed, that may not have been so easy to find by just reading through things themselves over time. I'm going to pass the mic to Ian for a bit.
Yeah. Okay. So our data set was stories from BBC and Reuters. We got stories related to the Ukraine war, about 30,000 of them altogether. So this is basically unstructured text. We didn't use any of the metadata from them, except the dates of the articles. And from there, we ran it through a couple of processes. One was an entity extraction process, and the other was a relationship extraction process between those entities. When we finally got done running everything through, we ended up with a huge number of relationships. About 380,000. So we ended up filtering it down. The entity extraction was done. Actually, I think it's on the next slide if you go forward, Karina. Yeah. Okay. Well, there's a little bit on here. So basically, the entities are the nodes on the ends of the picture here, and the relationship in this case is the employer. And so Spacey gave us the entities, and specifically the entity types, which was very important. Rebel would give us entities and relationships, but it wouldn't tell us the types of those. And we really wanted to know the types of the entities to break them down by things like person or organization or location. So we ended up with about 380,000 of them. Rebel is a large language model specifically fine-tuned or trained around this task. It was trained on news articles, which is one of the reasons we used it. We tried a bunch of other packages in this space, but this seemed to work best because there's ones trained on things like biomedical data and such that didn't work well for us, obviously. As such, as part of forming it up, it's also created a list of relationships, about 100 relationships, or about 200 relationships, I should say. And so we had to filter that way down to ones that were useful. A lot of cleaning up, things like that. Yeah. And that was one challenge. Another challenge was just how do we exchange data between these organizations? It turns out our organizations weren't so happy with sharing big collections of text around, even though they're actually public articles. They're on our websites, but so just to get around a lot of things of legal people signing off on things, we created a sort of interchange format. And the interchange format consists of a subject, an object. The basic core of it is a subject-object relationship, and a date. And the date comes from the article. We also have a couple of other pieces that aren't in here. The URL back to the original article is in there. We also have the subject and object types indicated in there. So we ran into a lot of issues with it. There were some errors from the extraction itself, where it extracted information that wasn't correct. One thing that came up a lot was that Reuters and BBC, just because they're mentioned not in every article, but they're in every body of text that we had, tended to end up, owning things like Crimean Bridge and such. So we had to remove a lot of things like that. That's just an artifact of the extraction process. Yeah, there was a lot of noisy things that we weren't interested in for our task. And there were also things like a lot of duplicates. So there's sort of two definitions here. If we were making a normal graph and we have like something that comes up a lot, like Vladimir Putin is the president of Russia, that comes up in a lot of articles, but they're often on different dates. So if they occur on different dates in a normal knowledge graph where it wasn't temporal, we would probably try to filter those down to just one relationship. In this case, we have kept them all because that fact was reaffirmed on multiple dates. And that's interesting when you get to a lot of the other events and things. Can you go forward to the next slide, Karina?
Yep.
Okay. Oh, this is you, right?
Yeah. So a third element here, after extracting the data and mapping out the relationships, was actually to enrich it with OCCRP data. OCCRP has a data platform that's called Aleph, which contains like millions of government records and open data that we were hoping to enrich these entities with. So as you pull out an oligarch, we can hopefully, use the Aleph data to also see what companies they may be connected to, et cetera. And one of the, I guess, challenges, but that was quickly solved by enriching it with Aleph, was finding a data schema that worked well. And we decided to go to look at the follow the money data model, which is what Aleph is using. And the benefit of agreeing on a data schema like this is that it kind of helps to reduce a lot of the noise. You can meaningfully represent the relationships. So you're not looking at things, as Ian was discussing, like, Russia and Ukraine share a border, but something a bit more meaningful, like this individual owns this company. And it kind of just keeps the level of detail more manageable and easy to search and make sense of once it's put into the database or the tool rather. And so where we're at so far with that, it got a little bit complicated, but we've successfully mapped about 3,000 of these test entities from the Reuters and BBC data into Aleph, or into the follow the money schema. And we got into a little bit of trouble because we should have done a bit more cleaning of those connections before mapping it. But as I said before, the real value here is that you can see entities with the same name, and kind of follow and build out those connections from with data that isn't actually in the Reuters and BBC stories, but in these public records and such that Aleph contains. So it kind of helps to contextualize these relationships beyond what you're seeing in the articles. Here's a quick example. I think we're running a long time, but here's kind of like what it would look like when the relationships are mapped into Aleph. So you can see these are relationships that we've extracted using Spacey and Rebel. And then once we've mapped them into Aleph, you can actually visualize them in this way. So you'll see that, Vladimir Putin, his relationships, etc. And then see others that may be connected to him based on their relationships with the same entities. And here's a quick video of kind of what the final tool ended up looking like. So here's an example where we took Alisher Usmanov, who's a notorious oligarch that we've done a lot of reporting on. And when you type in his name, you can see all of his connections. So you can see companies that he's owned, the date that that story was published, that kind of brings up those connections. And then there's a link to the actual story. See in this example on the Reuters website, where you can actually read more about that connection between Usmanov and that company, Megaphone. And I can't change slides. Okay, here we go. Yeah.
Yeah, so technical takeaways. Spacey and Rebel, they do save times. Or they do save a lot of time for us. But my general feeling is that getting really perfect relationships and entities extracted from unstructured text is still challenging. We still ended up doing a lot of cleaning up of things. So I have to think a bit more about how to go forward with that. I feel like we could do so much more with this data, though, even with what we've got. We could extract better. I think the relationship descriptions, having 200 relationships is certainly too many. And I think we could probably hone down on a much smaller number of them that are more useful for what our journalists might like. Another thing is times. We took the times from the articles. And in a lot of cases, that's pretty good. But of course, there's also follow-up sections in those articles, and where they're telling us what happened in the past. And sometimes it would also extract a date for that too, as one of the entities. But generally, we've just been working with the times from the articles. And that made putting together event timelines a bit tricky. Sometimes there were some things in there that weren't quite right. So we got to think a bit more about that too. Go ahead, Karina.
And yeah, just to kind of wrap it all up, there were some takeaways that we had from like the product side as well. We very early on, had a really nice session where we prototyped the product on paper, and kind of drew out exactly what we wanted it to look like and why and how it should kind of work. And we were pretty happy with ourselves. But then when it came time to actually physically prototyping. We, ran into a lot more challenges than we actually thought we would. So, looking back in hindsight, we probably should have started a bit earlier. We should have started with the real world data that we were extracting from the stories and worked in more of a sprint mode to actually, turn our ideas into an actual product, that looked more like what we had envisioned from the beginning when we set out to create this.
We should have found a UX person. None of us were UX people. Yeah.
And that's all.
Amazing. Thank you, Karina, and thank you, Ian. Great presentation and great work on this very elaborate project. So kudos to you all. We have time for one question, and I think we have one question too from Simon Frantz, who asks how much time was spent on mapping and cleaning connections in entities, and what did you learn about how to do this more thoroughly or effectively?
I think we tried a number of different automated ways. We're looking for a piece of software that would kind of do most of the work for us. And then when we didn't find one that was giving us quite what we want, we went with the best choice and then ended up doing a lot of cleaning. So I think there was a lot of cleaning in a short time period. I used all the different tricks, statistical analyses, a lot of approximate string matching, hand mapping in cases, all those kinds of things. It's not the first time I've done this kind of stuff a lot, but I keep hoping it'll get better. And it is better than it used to be for doing this, but we're still not in a world where it's perfect yet. So yeah, more time than I wanted is probably the answer of how much data cleaning time was spent. I still haven't seen something where you can give it a bunch of unstructured text like this and you get out really great knowledge graph, database ready kind of stuff. And if anybody else has ideas on that, I'd love to hear about them.